Okay, general chemistry. Here is your walkthrough for your notes for significant figures. I'll be back on Wednesday of this week, which I'm looking forward to. Before I left, we talked about how to measure properly using a device, and we looked at this, measuring this little block, and we said this particular block could be measured 1.38, 37, or 36. And I just want you to remember that we said that there were certain digits. Those are digits where the device has a mark for that distance, and we're certainly above the 1.3 and less than the 1.4. So everyone who measures using this device would get the 1 and the 3. And then we would get to estimate one additional digit, which you get to eyeball between these marks, what you think that is, 0.7, 0.6, whatever it is. And we use that rule for every measuring device. A measurement must be one past the marks on the device. We did other measurements, like the bottom of the meniscus for a device. And again, we have certain digits here, being the 6 and the 3. We're definitely above 63, but below 64. So we can be certain about the 6 and the 3. And we get to estimate to the 10th, one past the marks on the device. You can do that again on this device. And the point of this, going back to look at it, is we measure, or we take our measurements, the numbers that we get for our measurements, and this precision of this device, which this device has marks every 1 milliliter, allows us to get to the 1/10 of a milliliter. And because of that, we get 3 units on our measurement. And these 3 spots we call significant figures. They're every known digit or certain digit. This could be certain. Every certain digit plus the one unknown, or we've been calling this the estimated digit. And this is a system that we use to keep track of precision in our measurements. And you'll see why in a second, but basically when we do math with these numbers, if we want to measure the density of this liquid, for example, we have to report our answer somehow to include the same precision that our device measured. In other words, we can't do math with this measurement, and then we calculate our density and we report our density like this. We get a ton of extra units and we say this many grams per cubic centimeter. Okay, we cannot do that. We have to keep our precision in our measurement. So because of that, we have something called significant figures. Significant figures are a way to keep track of these digits. And if we didn't measure it, how do we know how to keep track of these? There's a set of rules, and there's 4 rules. And these are straight from your textbook. Every non-zero digit is significant. And I would write down these rules if I were you. This would be something like a number like 157. Every one of these numbers in this measurement, or whatever you want to call it, is non-zero. So we have 3 different numbers here. They're all non-zero. All of these would be significant figures, and we would say this has 3 sig, I'm going to abbreviate, figs. Okay, if we had another number, maybe we have something like this, 3,589. Every single one of these is a significant digit because it's non-zero. So this has 4 significant figures. Okay. Everything that's non-zero counts. 2 interior zeros. These are zeros that are sandwiched between 2 non-zero digits. They're always significant. So maybe you have a measurement like this, 105. This zero that's between these is between 2 non-zero digits that are significant. And so that zero counts. And so this would be 3 sig figs. And this could be more than 1 zero sandwiched in between. You could have something like this, 2007, and both of these ones between count. All interior zeros count, so this would have 4 significant figures. And this is a way to keep track of our precision in our measurements. Number 3, leading zeros. These are zeros to the left of the first non-zero digit, and they're not significant. They only serve to locate the decimal point. What does this look like? Zeros to the left of the first non-zero digit. It'd be something like this. 0.0052. All of these zeros to the left of our first non-zero digit. Here's our first non-zero digit coming from the left side. These ones don't count. They're just spacing the decimal. That's the only way for us to write this number, unless we write it in scientific notation. So these zeros don't count, but this counts because it's a non-zero number, and so is the 2. And so this would have 2 significant figures. If we do something like this and put a bunch of zeros in front, these zeros in the front do not count. They're spacing the decimal. So the only thing that counts is the 3, the 7, and the 5, and this would have 3 significant figures. Okay. Rule number 4 is for trailing zeros. Those are zeros at the end of a number. And there's kind of a couple different categories of these. Trailing zeros after a decimal point always count. So if we have something like this, let's do 152.00. These are zeros that are after a decimal point, and they count. These count because they're a non-zero number, so we get 1, 2, 3, 4, 5 spots. So this has 5 significant figures. Okay, let's do one more like this. Trailing zeros after a decimal point are always significant. How about something like this? 267.550. That 0 counts. It's after a decimal point, and it's at the very end. It's a trailing 0. So this one counts. What if we did this? Would it still count? Yes, it would, because now it's sandwiched between both of those numbers, which would go back to this rule number here. Number 2, interior zeros count, and so that would count as well. What happens if I put zeros at the end like this? Yep, all those zeros count because they're at the end of a number after a decimal point. So this would have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 significant figures. Okay. Trailing zeros before a decimal point and after a non-zero number are always significant. Trailing zeros before a decimal point and after a non-zero number. Oops. So let me write this in. Might be something like this. Here's a trailing 0 before a decimal point and after a non-zero number, after 2, are always significant. So let's put it like this. This would have to count. Okay, it's sandwiched between 2 numbers, so that counts for our interior zeros. Let's make it so it's not sandwiched between 2 numbers. Now does it count? It does. It still counts. Trailing zeros after decimal point are always significant, so this one counts. It's after decimal point. This one's before a decimal point and after a non-zero number, and it's significant as well. So 1, 2, 3, we'd get all 3 of these spots. Okay, the last one's your one exception. So everything counts so far here for trailing zeros. Trailing zeros before an implied decimal point are ambiguous and should be avoided by using scientific notation. These do not count. So if we write a number like this, 1200, the implied decimal point that's not written in this number is right at the end here, the little decimal. And I just wrote it in here. Some books will write it in like that. And if they put the decimal, that means they want you to count these zeros here. This book doesn't do that. If we just write 1200, we don't count these zeros here. And so this would only have 2 significant figures. This is kind of your only other zero that doesn't count. So these guys don't count. If I have maybe 2 million, all of these zeros do not count. They're just holding the spot for this decimal. Only the 2 counts, and this would only have 1 significant figure. Okay. So I would put a star next to this. These are the zeros that don't count, and these guys right here are the zeros that don't count when you're spacing decimal from the front. Everything else does count, okay? So if you wanted to write this with more significant figures, you'd have to write this in scientific notation, and we could write something like this, 1.200 times 10 to the, what do I need to do? To the positive third, 1, 2, 3, and that would now have 4 significant figures, okay? So those are your rules. I hope that helps. We're going to apply those. Go ahead and pause the video and see if you can figure out how many significant figures each of these numbers has. Okay, I hope you had the chance to evaluate these. These are the zeros in the front, which would be rule number 3, leading zeros. Zeros to the left of the first non-zero digit. Here's my first non-zero digit, and we're to the left of it. And these ones do not count. They're just spacing. So this one is the only one that counts. This has one significant figure. One, I'll just abbreviate SF. These guys don't count. These are the ambiguous ones at the end. There's an implied decimal here. We didn't write it, but it is implied there. These ones don't count. This one does because it's non-zero. So this also has one significant figure. Okay. Here's my zero in front. That's just like part A here. These zeros don't count. Okay. This one doesn't count. But these ones do count because they're after a decimal. They're at the end of our number. What's our rule here? This is trailing zeros after a decimal point are always significant. That's this guy right here. And so we're going to count these, and we count the 2 because it's non-zero, so this has 3 significant figures. Here's one that's just spacing our decimal. We don't count this one, just like we didn't up here. Okay, but we count the 1 and the 2, so this has 2 significant figures. Okay, these ones in the front don't count. These are leading zeros. But this one at the end does. It's after a decimal, and it's after a number. And so this would have 2 significant figures. Okay, we count these 2, and that means we have to count the 0 in between because it's sandwiched in between. It's an interior 0. And then these are zeros after decimal. They always count. And so 1, 2, 3, 4, 5, everything counts here. This would have 5 significant figures. If you have scientific notation, you don't worry about this with significant figures. We only look at our number over here. We have 2 significant figures. And we have 1, 2, 3, 4 significant figures here. All these zeros count. This one's sandwiched in between, and this one's after a decimal, and it counts. Okay. If you have exact numbers, these are numbers that are not a measurement. These numbers are not considered when we keep track of significant figures when we do mathematical calculations. So an exact number would be something like an accounting number. If you count how many students are in the class and you get exactly 18, we mean exactly 18.00000 forever, no more and no less, but we just say 18 students. These are exact numbers. If you have an exact conversion, like there's 5,280 feet in 1 mile, that's exact, and it's exactly 1.00000 forever. Miles equals 5,280.000 forever feet. If you're using an exact conversion, we don't worry about how many significant figures this conversion has because it's exactly precise, 100% precision. Okay, when we're doing addition or subtraction with numbers that we want to keep track of our precision, our significant figures, we have a couple rules. For addition and subtraction, you complete the calculation, and then you round your answer to the least number of decimals, not significant figures, in your original numbers. So you can write down this example in your notes. 2.06 plus 18.1. We're going to do our math first. That's 20.16. So complete the calculation first. That's our first step. And then round to the least number of decimals in the original numbers. So my original numbers have 2 decimals here. I'll just abbreviate DC. And this one only has 1 decimal point. So we want to round to the least number of decimals. That's this, 1 decimal, in my final answer. So I'm going to round to right here. So I only have 1 decimal point. And this will become 20. The 6 tells us to round up, 20.2. And that'll be our final answer. Okay. If you're doing, and that's true for all addition and subtraction, if you had 10 numbers that you were adding or subtracting, or adding and then subtracting, you can do all 10 of those additions and subtractions. And at the very end, look at all 10 numbers. Whichever number has the least number of decimals will determine what your final answer needs to have for the least number of decimals to match. Multiplication and division, same thing. Perform the calculation first, and then your answer gets the same number of sig figs, not decimals, as the original value with the least number of significant figures. So now we're keeping track of significant figures. So in this case, we're going to multiply these 2 together, perform the calculation. We get this, 22.886. A meter times a meter is a meter squared. Those would be my units. And now I'm going to go to my original values, and I want to know how many significant figures do they have. So this one has 1, 2, 3 sig figs. This one has 1, 2, 3, 4, 5. Easy numbers here. All of them count because they're all non-zero. So my least number of sig figs would be 3. So my answer needs to have 3. So 1, 2, start on the left. 1, 2, 3. We want to round to this spot right here. And the 8 afterwards tells us to round our 8 up. So this becomes 22.9 meters squared. And there's my correct mathematical calculation that keeps the least amount of precision in my original numbers. So our answer here is limited to the 3.15. If we could pay more for that calculation, have a better device or whatever it is, we could add 2 more digits to this calculation here. If we did, then our answer would get 2 more digits as well. We would get all 5 sig figs. Okay, so go ahead and try that out here. Pause the video and see if you can do this math with the correct number of significant figures. Okay, I hope you had the chance to do that. The first step is always to do the calculation. So here's your calculation for our first one. And now let's walk through how we get our answer here. If you're adding, you do least number of decimals. This has 3 decimal spots and this has 2 decimal spots. So my answer needs to have 2 decimal spots. That's the 2 and the 3. We're dropping out the 4 and we get our 7.23 inches. Again, we're subtracting, so we count decimal spots. There's 2 decimal spots and there's 2 decimal spots. Our answer gets 2 decimal spots. You don't have to do anything to this one. This one's already the correct amount. We're dividing here. Do our division first. And then because we're dividing, we want the least number of significant figures. This has 1, 2, 3 significant figures. This has 1, 2, 3, 4 significant figures. The 0 counts, it's sandwiched in between. And so our answer should have the least number of significant figures, which is 3. 1, 2, 3. I'm going to round to this 6th spot. And that rounds up because I have an 8 afterwards, and that's how they get their 0.847. Remember, this front 0 does not count. It's not significant. It's just spacing the decimal. This last one, they multiply it out and they get 19.74. 3 pencils. This has to be a counting number. And since it's a counting number, this is exact. We had exactly 3 pencils. We counted them. Because it's exact, this has an infinite number of significant figures. We don't use this to calculate our final answer or to figure out how many significant figures our final answer should have. So we don't need to count for that one. It only has 1 significant figure, but because it's an exact number, we don't use it. So we go into this one. We have 3 significant figures. So we want 3, 1, 2, 3. We want to round to the 7th spot. The 4 tells us to round down, and we get 19.7. Okay, I hope that helps. You have a significant figures and assignment on Mastering Chemistry. Your assignment on Mastering Chemistry is 1.4, the classification properties of matter. You have today and tomorrow to work on both of these assignments. It's already posted on Mastering Chemistry, and it covers your reading from last week. It should take you like 25 minutes or so. Then you have 1.5. This is posted on Google Classroom. It's significant figures. It's what we just talked about and took notes on. And at the end of your chapter 1 in your book, you want to do these exercises. Odds are in the back of your book. The answers are. So you can check those. Complete it on a separate sheet of paper, and you'll turn in a hard copy. Please work on both of these assignments the next 2 days. Email me if you have any questions. I'd be glad to help out.